Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Let's begin the lecture. Today we're going to begin talking about operations on a single random variable. طبعا last chapter 2, as you recall, we introduced the random variable along with the CDF and PDF for random variable. And also we had a few examples on that. So we assume that we understand the random variable very well. So chapter 3 will be a follow-up. We're going to continue with the discussion on random variables, where we're going to introduce some operations that we can use on a single random variable. Of course, in chapter 4, we're gonna talk about multiple random variables, or at least more than one random variable, maybe 2, maybe 3. We'll find out. So as you can see on the screen, these notes here, it's already on e-learning. So let's walk you through it quickly. I'm assuming today's lecture is going to be a bit short. I'm getting, we have enough time, so I'm not going to go through the material quickly. So we're gonna cover the material one bit at a time, so we try to understand it. So for example, chapter 3 here, today we're gonna talk about the expected value of a random variable. So the first operation we're gonna talk about today for a single random variable is the expectation. So the expected value of a random variable, it's basically it's given in equation 1, as you can see here, which is basically the integration of the PDF for that random variable times x, okay? And this is the notation E of x. This is the notation for the expected value, okay? So it's very simple. So if you have the PDF, of course, we did talk about the PDF in chapter 2. So if we are given the PDF, all we have to do just to the integration of that PDF times x from minus infinity to infinity. Okay. Now, as far as the notations, مثل ما حكينا, the notation for the expected value is E of x. Other notations, x bar, as you can see here, or mu. All of them, they mean the same thing. So some books, they use these notations. Some books, they use both notations. It doesn't matter, as long as we understand these notations are expected values. Also, the expected values, sometimes we refer to it as mean or statistical average. So these are interchangeable, changeable terms, okay? So they all mean the same thing. Now, if the expected value is a discrete random variable, okay? Now, this equation here we just talked about, this is a general form, a general form to find the expected value for both discrete or continuous. Now, if the expected value, the discrete random variable, of course, the PDF for it is in equation 2, and we've seen this one before, which is basically the PMF for each value of x times the impulse function, okay? Where the impulse function is shifted by the value to the right, of course, okay? X minus xi, okay? So you do the summation for this. So this PDF, we did talk about it last lecture, okay? Now, if we have this PDF for a discrete random variable, all we have to do just plug in equation 2 in equation 1, and we'll end up with equation 3, which is the expected value of a discrete random variable. And as you can see, the expected value of a discrete random variable, it's basically each possible value of x, okay, times the PMF for that x. So you sum all the values. So you do one at the time. The value times its PMF, the second value times its PMF, and after that you sum them all. That's all. Here on the right-hand side, and I'm showing you how we ended up with equation 3 by using this this identity or this equation, okay? Because when you take the integration of x times the impulse function, it's going to be the value itself, which is shifted right here, x naught. Okay, so just in case if you want to know how we ended up in equation 3, so you just take this one, and of course PMF here, these are constant, so they will be out, they will stay the same. So the integration will be just the integration of the impulse function times x, okay? And the integration of the impulse function here, it will be x naught in this case, or xi in this case, okay? All right. Any questions so far? Okay. Let's go to page 49. Page 49, we have a simple example, example 1. And this is straightforward. For a discrete random variable, we have values. For that discrete random variable, we have 5 values, as you can see, 1, 2, 4, 7, 11. And also we have the probabilities or the PMFs for each value. So for example, value number 1, the PMF for it is 0.35. Value number 2, the PMF is 0.1, and so on and so forth. So now what we have the values and the PMFs, and we need to find the mean function, the expected value of this random variable. So what do? We just go back to this equation 3 right here. And like I just said, you just take the value times its PMF, and you do that for each one of them, and you sum them up. So 0.35 times 1, 0.1 times 2, 0.15 times 4, and so on. So this is basically when you have a random variable. So you just take each value, multiply by its probability or PMF, and you would end up with this summation, or this mean value, or expected value. Example 2. Example 2, the random variable, it's a uniform random variable over the interval of -4 and 9. So, and just to refresh your memory from last lecture, if you remember, we talked about some random variables. Of course, the first random variable we talked about was the Gaussian. We went through a lot of details on that, but last lecture we introduced some more random variables. One of them was the uniform random variable, and also we talked about expected value, the exponential random variable, and Rayleigh random variable, and things like that. So, and all we did, we just introduced the PDF and the CDF for those random variables. Now the applications for those random variables, we may see it here. So, for example, example 2 here, we have the uniform random variable has the limitation -4 and 9. Of course, the limitation here is A and B, and this is the PDF which was introduced last lecture, if you remember. So if you plug in B and A here, and the PDF for this random variable will be 1/13, where x between -4 and 9. So we take this information, okay, and just plug it back into equation 1 here. So we have the PDF times x, and we do the integration. The integration going to be between -4 and 9, okay, because this is the interval or the limitation, okay. So we just do the math right here quickly. As you can see here, we all know how to do it. And so the mu, or the expected value of this random variable, uniform random variable, is 2.5, as shown in equation 5. Another example where we have the PDF, in this case, is an exponential PDF, okay? The PDF, the random variable x is exponential random variable, okay? And the PDF for it is given in equation 6, as you can see here. Okay, now if you go back to last lecture, we had 2 forms of the exponential PDF, where we have A was shifted to the right, and A was 0. So in this case, A was 0. If you forgot that, just go back to previous lecture, and you can see what I'm talking about. But it doesn't matter. This is the PDF we are interested in, which is all positive numbers, U of x. Okay. Now what we need to find the expected value of this random variable. And again, very straightforward. We just use the equation number 1 on previous page. And after you do the math, it's going to be from 0 to infinity, since we have the unit step function here. Okay, so it's going to be from 0 to infinity. So when you do the integration, it's going to be equal to gamma. Now, how did we end up here? Of course, when we have something like this, maybe you can solve this by using integration by parts. And by the way, I expect everyone to know how to do integration by parts. It's very straightforward. Nothing to it, and we all, we've seen it before in math courses or any other courses, physics or anything like that. I don't know, but this is something it's very common to engineers. Okay. So just to refresh your memory, in case you forgot how to do it, or I suggest you do this one here. I do a couple more times in case you have to do it in the near future. So the integration by parts is, as you can see here, it's shown in equation 8, okay, which is the integration of u dv equal uv minus the integration of v du. Now, what I did here, I assume that u in this case is equal x right here, and the exponential part, the exponential function, it's equal dv. So when u is equal x, d of u is equal 1d. طبعا take the derivative, and this one here we need to find v, so we do the integration. It's very straightforward. Going to be minus gamma times the exponential minus x divided by gamma. Okay, so we just take this information, u, du, dv, and b right here, and just plug them into equation 8, and you would end up with this equation right here. So the first part here is going to be equal to 0 because u is x مثل ما حكينا, and v is right here. So, and we're gonna do the integration or the limitation from 0 to infinity. So when we plug in infinity in the exponential right here, minus x, gonna be 0. So the whole thing gonna be 0, and 0 when you replace x with 0, of course the whole part will be 0, and that's why the first part here is equal to 0. And then when this one here, this is just straightforward integration. We all know how to do it. So that's why how we ended up with gamma. Okay. So I suggest that we understand how we do the integration by parts. Okay. The next page is talking about expected values of functions of random variables. So what that is, it's basically the same thing. It's basically now we are dealing with a function of the random variable instead of the random variable itself. So given a random variable x with the PDF, so the PDF of the random x is fx. Now the expected value of a random variable g of x, okay, of that random variable. So what we have here, we have the PDF and we have a function of the random variable, and we need to find the expected value or the mean or the average of that function of the random variable, not the random variable itself, the function of it. Okay, so all we have to do is take the function times the PDF and do the integration from minus infinity to infinity. Now, if we compare this one, this equation 9 with equation 2, for example, you see they are the same. The only thing we replaced x right here in equation 1 with the function of x, g of x, and we did the integration. Okay, so it's very, for example, maybe in the g of x in this case is g squared. X squared. If it's x squared, just we replace x with x squared, for example. Okay, and of course, if the random variable is discrete, the same thing we replaced. If we go back to page 1, or page 48 rather, and equation 3, we replace x of I here with g of x bar. And everything is still the same, no change. Okay. And the last two equations, equation 11 and equation 12, basically these are identities. We're going to use them later on. They will help us to analyze, some equations, or let's say simplify them, if you will. Always, when you have identities, we use them to simplify our analysis, our equations, make them easier to deal with. Okay. So, for example, here, equation 11, it says the expected value of a of x, a times x plus b, it's equal to the a times the expected value of x plus b, where a and b are constant. And of course, that's correct, because if you, of course, when you do the integration for constant, the constant will always going to be out. Okay. So, for example, here, so all you have to do, just if you have a constant, just take it out. The expected value of a of x, so it's going to be a expected value of x. So you just take the expected value of the random variable x times the constant a plus b. And number 12, basically it says here, if we have multiple functions, okay, multiple g of x, multiple functions of x, okay, the expected value of these multiple functions, the expected value of the summation, the expected value of the summation of these multiple functions is equal the summation of the expected value of each individual function. So if you have multiple functions, okay, let's say if we have 10 functions of x, 10 different functions of x, and we want to sum them up, okay, and we need to find the expected value of all these summed together. What you can do is just take the expected value of each individual function, okay, and sum them up. So it's the same thing. Either you do the expected value of the summation, or you do the expected value of each individual function, and then you sum the expectation. Okay, so we'll give you the same answer. And this is the end of today's lecture. Okay, and next time we're going to talk about moments and things like that. So I'm not gonna go and introduce something else. I want you to understand the expectation and the random variables. So we're gonna go step by step to make sure we understand this chapter and previous chapter, because these are very important to understand these two chapters. Of course, everything that will make it easier for us to understand chapter 4 and chapter 5 and the rest of the lecture, the rest of the course. Okay. Any questions so far?
يعطيك العافية دكتور.
اوكي الله يعافيك. اوكي.
بدي أسألك
تفضل.
بالنسبة للمد شو راح تكون الماد تتوقع يعني لحد الآن؟
المد هو كأنه 8 12 something like that، يعني بعد تقريبا عندنا اسبوعين تقريبا. I'm assuming that by then we will finish at least chapter 3. فالمد راح يكون up to chapter 3، يعني مثل ما تقول بنحاول يعني chapter 3 بتوقع راح نكمله let's say sometimes next week. okay، يعني ممكن by next Tuesday، مش this coming Tuesday، next Tuesday نكون مكملين chapter 3. فالمد راح يكون over chapter 1 2 and 3. okay، that's my expectation. طبعا حتى لو انه صار معنا وقت نبدا بchapter 4، I think رايحين على قليل المد. I feel إنه خلص يعني up to chapter 3 will be good enough. Okay.
إن شاء الله.
إن شاء الله. Any other questions? Okay. If you didn't have any questions إن شاء الله بنشوفكم نحكي معكم إن شاء الله يوم الثلاثاء، ويعطيكم ألف عافية.
يعطيك العافية دكتور.
شكرا.